Hi, John. Thank you for taking the time to meet with me today. I will be discussing our approach at solving IBM's high attrition rate problem. The current challenge is that IBM is reactive rather than proactive, which leads to a high attrition rate. This is important because attrition can be very costly. We were looking at some numbers from Glassdoor, and we were able to estimate that a 20 to 30% reduction in attrition can lead to about $200,000 to over $500,000 saved annually. In order to do this, we've leveraged AI and machine learning to predict high-risk employees. That way, we can provide intervention methods before they decide to leave. To do this, we first started with a data set that had 1,470 employees and 35 features. These features consisted of things like demographics, compensation, job role, job level, things like that. And in our data set, there are no missing values. Some of the challenges we had was that majority of the data was attrition equal to no. So to handle this, we used SMOT oversampling to prevent any bias. We also had 9 categorical features and we hot encoded these. And then we did some feature engineering, such as creating tenure buckets or income ratios, things like that. And then, as this is HR data, ethics and governance is very important. So we made sure that no identifiable information was stored in the data set. We made sure that our model is not biased. And we always kept the end user at top of mind and made sure that the results are very interpretable using SHAP values. So for our model, we use XGBoost classifier, and we did this because it's very accurate and it handles imbalanced data very well, which is what we were working with. Our setup was 80-20 train test split. Again, we handled the class imbalance with SMOT, and then again, we use SHAP values for full model transparency and trust. Our model had a ROC AUC of 0.69 and then a precision recall AUC of 0.26, which is something we hope to improve with further investment. And we also wanted to note that accuracy was not really emphasized here due to the class imbalance. And then we also included some interpretation notes here. So 0 equals stayed, 1 equals left. We have defined some of our key metrics, such as precision, recall, and then our SHAP analysis, which explains our features and the role they played in the prediction of the employees' attrition versus not attrition. So to recap, we first started with a strong data foundation. Then we built a balanced and explainable model. And then we addressed governance and ethics upfront. So bringing this all together, we've created an interactive dashboard. This is for HR or the leadership team or really anyone who has direct reports, and they can explore the attrition rate in real time. They can predict high-risk employees. So we can go ahead and take a look at the dashboard right now. So it has 3 tabs overall. The first is the analytics tab. So this is where you can do some simple EDA, looking at key metrics, some breakdown of attrition by department and job role, and then some KPIs down here at the bottom. We also have a tab where you can predict the high-risk employees. So this graph right here is showing you the top features influence attrition overall. Then we have the section where you can actually predict your high-risk employees. So this is fully customizable and can be edited here. And then it shows you the prediction rate result down here. So this person with these metrics has about a 28% chance of leaving. And then this is the SHAP graph down here, which shows you which features contributed to that percentage the most. And then we also have a breakdown of the model information for any of the end users who are interested in that. And our last page is the cost analysis page. So this is the current state without any machine learning. So we see that attrition is a total cost of 1.4 million. Then if we use machine learning, we see that we can predict some people who are at risk of leaving. And let's say we save about 50% of those people. So that would mean 10 employees are saved through intervention methods. And this would bring down our attrition costs to 1.1 million. And then so down here we have a summary of the financial impact. And you can see that we have that $300,000 estimated savings. So that is our dashboard. And for our ask, we do need some materials. So the model is hosted on AWS, and we need to make sure that the data is stored securely, which would be an estimated cost of about $1,000 per month. For our team, we would require one data scientist and one software engineer. And the time commitment would be about 6 to 8 weeks to fully deploy this dashboard into a scalable dashboard for the company to use. And then after that, it would be light monthly maintenance. This is our presentation, and this is what we believe can help IBM solve their high attrition rate problem. If you have any questions, please feel free to reach out. Thank you.